Welcome to Math 1324. This is Chapter 5, Section 2, Example 5. And in this example, we're going to start at age 50. A woman puts $1,300 at the end of each quarter into a retirement account that pays 7% interest compounded quarterly. When she reaches age 60, she withdraws the entire amount and places it in a mutual fund account that pays 9% compounded monthly. From then on, she deposits $400 in the same mutual fund at the end of each month. How much is in the account when she reaches 65? Okay, I'll be honest with you. At this point, it is easiest to use the TVM solver. I'll go ahead and show you how you do this with the formulas, but for now, it's actually easiest to do it with the TVM solver. So I'm going to go ahead and start with the formulas and then show you how much easier it is with the solver. Okay, so let's read what we want to figure out. How much is in the account when she reaches age 65? Okay, so that's what we want to know. But first, we have two different times that she's making payments. She starts at age 50, and then she stops when she reaches age 60. Okay, so she's putting $1,300 at the end of each quarter into a retirement account that pays 7% interest compounded quarterly. Okay, so what we want to do is we want to figure out from this information how much money did she accumulate from the age 50 to age 60. That's what we need to know first. That's only the first step here. Okay, so again, we have A, capital R, little r, and T. Or if you prefer, aren't. I'm sorry. Anyway, we don't know that future value that we're creating here. The capital R is the revenue stream, and she is making $1,300 payments. The interest rate is 7%, but as a decimal is 0.07. Little n is the compounding events per year, which would be 4 because it's compounded quarterly. And T is the time in years. Well, what's 60 minus 50? That'd be 10 years. In other words, for how long? She starts at age 50, goes to age 60. That's 10 years. So the formula is this. And then just type in our values. There it is. Now, I haven't typed this in, so I'm not sure what this is yet. But you've seen me type this in several times, so I'm not going to go to the calculator and just show you how to type that in. It's literally just type in the 1,300 times alpha y equals enter, type the numerator, then type the denominator, and just click enter. That's all it is. So I'm going to go ahead and do that, and you'll just kind of see a jump in the video, if I remember to take this out. Okay, so 1,300 times alpha y equals enter. Then 1 plus 0.07 over 4 to the 4 times 10. Then minus 1 all over 0.07 over 4. Okay. So the future value is going to be $74,404.37. Okay, now that's just when she reaches age 60, right? And she's going to have that amount, and she's actually going to transfer that amount into another account. Okay, so that amount is being transferred into a mutual fund, and that mutual fund pays 9% compounded monthly. Okay, so what I want to do is, this is actually asking us two more different questions at this point. Taking this amount and just putting it into an account and not doing anything with it anymore is just a compound interest question. A equals P times 1 plus R over N to the N times T. That's the formula we want to use here. So we need to know all of those values. So from that we have A, P, R, and T. Well, the future value is what we want to figure out from that. P is the present value, but the present value is how much she transfers into that account. And that is going to be $74,404.37. Good. Little r, again, is going to be a little bit different this time, which will be 9%, but as a decimal is 0.09. Little n is compounded monthly, so it's going to make that n to be 12. And t, what is t? Well, if she's reaching age 65, having started at age 60 this time, because that's whenever she put the money into the bank, 65 minus 60 is 5 years. In other words, in 5 years, how much will this amount then be worth in the bank account? Okay, again, so the formula here is actually different from your annuity formula. So this one up here is the annuity formula. This one down here is just the compound interest. The difference between the two is because for the compound interest one, we're just putting money in and doing nothing to it. You can always think of these as different revenue streams. And so annuity, there's multiple payments over time. For this one, we're just putting the money in and letting it grow. Yes, we are making payments into that account, but we can think of this as two different things. You should think of it as two different things, in fact. So because of that, we have to do two different formulas for this. So the first one, plugging everything in, P is the $74,404.37, and then times the 1 plus R of 0.09 over 12, all to the 12 times 5. Awesome. So I'm going to go ahead and type that in. And here's what I get. $116,493.51. Good deal. So there you go. That is the future value from having taken the accumulated value and just put it into a bank account. But that's not it. That's only partially the answer here. Because not only did she take the amount that she accumulated here, she's also depositing $400 in the same mutual fund at the end of each month. So the same interest rate, just she's actually creating a new annuity at this point. Okay, so let's see what that looks like. Again, the formula for annuity is the R times 1 plus R over N to the N times T minus 1 all over R over N. So we have A, capital R, little r, N, T. And again, we don't know what the future value is from that new annuity that we're creating. The revenue stream, R, is how much she puts in there a month, which is going to be $400. Little r is the interest rate, which we saw was 9%. The little n is the number of compounding events per year, which was 12, and time is 5. Now notice that this is very similar to this because it's the same account. It's just that you're treating this one-time payment of $74,000 as a separate issue. It's a separate issue from what you see here with the annuity. So annuities and just one-time payments must be handled separately. Okay, so let's plug this information in. So that means that A is going to be 400 parentheses 1 plus 0.09 over 12 all to the 12 times 5 minus 1 all over 0.09 over 12. All right, so I'm going to go ahead and type this into the calculator, and I will see you after I do that. Okay, I'm back. The value that I get is $30,169.65. Good deal. Again, this is only partial answer here. And the reason that I say partial is because what's actually in the account at that point will be the sum of this one plus this one. Okay, so the actual answer here is the total in the account is going to be the $116,493.51 plus the $30,169.65. And of course that means I need to type this in. And that will give me $146,663.16. And there you go. That's how much she will have in the account when she reaches age 65. Awesome. But as I said, this is actually easiest if we use the TVM solver. And I'll show you why in the next video. Have fun.